Alright, example 6. Determine if the following points are on the graph of the equation 2x minus y equals 6. Alright, the best way to figure out if a point is on a particular line is to just plug in the point. This is x, this is y, so I've got 2 times 2 minus 3, which is 4 minus 3. So the answer would be no, because 1 does not equal 6. Let's try part B. We've got 2 times 2 minus negative 2. 2 times 2 is 4, minus negative becomes a positive. 2 plus 4 is in fact 6. So this one is yes. You guys can try this one. Alright, graph the equation y equals negative 2x plus 3. Alright, there are lots of different ways you can graph a linear equation. Hopefully you guys can see that this is a linear equation. A linear equation, the word linear means that it makes a straight line. Okay, so whatever graph we get, it should be a straight line. I'm going to graph this by plotting points. Whoops. Kind of crooked. There we go. So just pick 2 points. Let's plug in 0 for x and let's plug in 1 for x and see what we get. So if I plug in 0, y equals negative 2 times 0 plus 3, y equals 3. This one's 3. Now let's plug in 1. Y equals negative 2 times 1 plus 3. Negative 2 plus 3 is 1. Okay? So now we can graph it. With a linear equation, as long as you have 2 points, you're good. You don't need more than 2 points because it makes a straight line. I'll show you why that is. I guess orange, okay. So 0, 3 is here, and 1, 1. So our line, okay, kind of straight. There's our line. Alright, let's try this one. Graph the equation y equals x squared. You guys, some of you guys probably know that x squared looks kind of like a u. It's called a parabola. I'm going to do the same thing here. I'm going to graph a few more points. Let's try negative 2, negative 1, 0, 1, and 2. I'll plug all these in. Negative 2 squared equals 4. Negative 1 squared equals 1. 0 squared equals 0. 1 squared equals 1. 2 squared equals 4. Okay, so let's go ahead and graph these. Okay. So, negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. So you can kind of see this is going to make a U. Alright, solve for y. So when it says solve for a certain variable, you want to isolate that variable. You want to get that variable all by itself. So what I'm going to do, I'm going to add 5 to both sides. So I've got 2y plus 3x, this cancels out, equals 9. I'm going to subtract 3x from both sides. 2y equals 9 minus 3x. Divide by 2. This cancels out. So y equals 9 minus 3x over 2. There you go. Okay, use a graphing calculator to graph this equation. Okay, before we can use a graphing calculator, in your graphing calculator you have to get y all by itself. So what I'm going to do is I'm going to isolate my y. So I'll subtract 6x squared from both sides. Aye. Oh well. This goes away. I've got 3y equals 36 minus 6x squared. Divide by 3. And this time we actually don't have to leave it as a fraction because this divides by 3 and this divides by 3. 36 divided by 3 is 12. 6x squared divided by 3 is 2. Okay, now we can pull out the calculator. Alright, here's your calculator. You're going to hit y equals, so y equals some equation. You're going to type this into there. So 12 minus 2x squared, and then hit graph. So there it is. I'm going to change my window just a little bit. Let's go from negative 20, let's go to negative 15. Now, anytime you want to zoom out, this window here, initially, the x's went from negative 10 to 10, and the y's went from negative 10 to 10. Now, when I graphed it, I saw that it actually was a little bit higher than the window, because this only goes up to 10. That's why I'm changing it from negative 15 to 15, just so you can see the vertex of the parabola. There you go. So it looks something like that. So we can graph it over here. Hey. If you had counted the lines, you would have seen that it actually hits at 12 and then goes down. Okay. And these ones, it hits somewhere in between 2 and 3. It actually hits at root 6. As we get farther along, we'll discuss why that is. Alright, you guys can try this one. Okay, create a table that displays the points of this graph. Okay, so first thing we gotta do is solve for y. Oh, my bad, this is the same equation as before. Alright, so we can just take out our calculator. Alright, so here's our graph. If you want to find the table, this is what you do. Right over the graph button, there's a little yellow table word. Hit second, hit that button, and there's your table. Okay. So you can get negative 3 is negative 6, negative 2 is 4, etc. Alright? You don't have to, they don't tell you to write it down, they just say to create it, so you've created it. Good work. Alright. Find the intercepts. We'll just say, check, we did it. Find the intercepts of the graph in the figure. What are the x-intercepts? What are the y-intercepts? Okay. The x-intercepts hit the x-axis. So the places where it hits the x-axis, here, here, and here. So, negative 3, 0, 3 over 2, 0, and 4.5, 0. Notice how for all the x-intercepts, the y value is 0. The y-intercepts hit the y-axis. So here, here, and here. So I've got 0, 3, 0, negative 4 over 3, and 0, negative 3.5. Okay, and notice how for the y-intercepts, the x value is all 0. You guys can try this one. Okay, use a graphing calculator to approximate the intercepts of this equation. Okay, let's pull out the calculator. They were nice enough to already solve for y for us, so I'll go to y equals x to the third power minus 16. Graph it. Okay, so you can tell it only has one intercept. It's not going to hit, let's see here. Let's zoom out a little bit. Let's go to negative 20. because it might hit the y-axis. It only hits the x-axis once, but yep, it does. So it hits here, and it hits here. So this is what I'm going to do. To calculate the x-intercept, I'm going to use a function called 0. So you're going to go to second, calculate. Calculate is right above trace. You're going to hit 0, 2. Because the x-intercept is also called the 0 of a function. I'm going to move, it's going to say left bound. Here, what you want to do is you want to put your cursor like somewhere to the left of the point that you're looking for. So this looks like it's right on there, so I'm going to move it right here. Hit enter. The right bound, you're going to move just to the right of it and hit enter. Then it's going to say guess. You hit enter again. So here you go. The 0 is 2.51-ish, or 52-ish. Okay. 2.52. This is the x-intercept. Finding the y-intercept is even easier. You're going to hit trace, and then just move your cursor until you get to x equals 0. Once you get to x equals 0, whatever y is, that's your y-intercept. So 0, 16 is the y-intercept. You could also do this algebraically, just by plugging in 0 for x or 0 for y, but the problem asked you to use a graphing calculator. That's why we did it the way that we did. Okay, so you guys can try this one, and that's all.